Lecture 11.3, Functions of Two or More Independent Variables. The functions that we have studied this year have all been functions of one independent variable. For example, f of x equals x squared, or f of x equals sine x. With more than one independent variable, we can do so much more. Here's an example of a function with two independent variables. In real life, functions often have more than one independent variable. For example, the area of a triangle A equals 1/2 BH is a function of the base and the height. We could write f of BH equals 1/2 BH. F of XYZ equals radical x squared plus y squared plus z squared could be interpreted as the length of the diagonal of a box. It could also be written W equals radical x squared plus y squared plus z squared. Functions with two independent variables can be represented graphically. This is not easy to do by hand, and our calculators do not do a great job either. For our example, we'll use z equals f of xy equals 100 minus x squared minus y squared. We will draw our graph on the standard XYZ coordinate system. Notice that the axes are turned so that we are looking at the octant that has positive values of x, y, and z. Also notice that we did not use the same scale on the z-axis that we used on the x and y-axis. This is what our graph looks like. We could also draw level curves. Level curves are drawn by holding the z-value constant, similar to contour lines on a topographic map. On a topographic map, the contour lines are lines of constant elevation. Another example of level curves can be seen on a weather map. Isobars are lines of constant barometric pressure. A different weather map might show lines of constant temperature, called isothermals. Let's look at the previous graph plotted on the TI-nspire. We first open a new graphing document. 3D graphing will not work in the sketchpad mode. Press Menu, 2, View, 3, 3D Graphing. Input the formula. z1 xy equals 100 minus x squared minus y squared. then press Enter. We don't see any graph. The problem is that the graph is outside the viewing window, or in this case, viewing box. Press Menu, 4, Range Zoom, 1, Range Settings. Here we'll input appropriate values for the viewing window. We'll have X go from -10 to 10, Y go from -10 to 10, Z go from 0 to 100. So we set the appropriate ranges, then press Enter. Press Menu, 4, Range Zoom, 2, Aspect Ratio. This is the aspect ratio that we'll choose. This means that 1 unit on the X or Y axis will be 5 times as long as 1 unit on the Z axis. Then press Enter. Now it looks pretty good. By pressing the arrow keys, you can rotate this graph. For continuous rotation, press Menu, 1, Actions, 8, Auto Rotation. To change the color of the graph, press Ctrl and the Grab key to select the graph. Then push Ctrl, Menu, 8, Color. You can choose different colors for the wireframe and for the upper and lower surfaces. This graph represents a function of 2 independent variables. The TI-nspire can also plot 3-dimensional barometric graphs where x, y, and z are functions of 1 or 2 independent parameters. This is beyond the scope of first-year calculus, but is something to look forward to.